Okay, great. Thank you. Just a minute. Okay. Hi, everyone. I'll be talking about vector today, or more specifically, what's new with vector. So I was just finishing up my fellowship's work on vector during the last PyHEP, and most of the work was not merged into the main branch of vector, or was not available on PyPI, but was rather available on the feature branches. And now that the work is over, like a lot has changed in vector, not specifically breaking changes, but a lot of new features, bug fixes, and quality of life improvement. So yes, let's jump into it. Okay, so a quick recap for like about what is vector and why you might want to use it, and maybe even a quick introduction for people who are listening about vector for the very first time. So vector is a Python library, a Python 3.8 plus library. If I remember correctly, vector 0.9 supported Python 3.6 and 0.11 or 0.11 supported Python 3.7. You can create, manipulate, and essentially perform physics, so 2D, 3D, and Lorentz vectors with the vector package. And the vector package or library comes with 3+2 backends. So a pure Python object backend, which means you can create vectors that are pure Python objects. A NumPy backend, which means you can create an array of vectors, a NumPy array of vectors, and an awkward backend, which is something that I think people use the most, and you can create awkward arrays of vectors with this backend. And then there are also Numba backends. Oops, this should be Numba-Awkward. So the object backend and the awkward backend supports Numba, so you can just-in-time compile your vectors. You can download or install vector through PyPI or through Conda. Okay, great. A very quick glimpse at all the backends, but believe me, you can do a lot more with vector, like a lot more than the examples I'm showing here. So all the backends have like a uniform API, so you can construct vectors with specific constructors. Like for pure Python vectors, you can use the OBJ constructors, and then you can perform a variety of operations on these vectors, anything that you would like to do with vector. So like adding to vectors or accessing the coordinate values of vector. But yes, you can do definitely a lot more than this. Similarly, there are NumPy vectors, which means you can create vectors out of NumPy arrays or a NumPy array of vectors, but these arrays are structured NumPy arrays. So you can use the vector.arr constructor, or you can, in the way that it's shown here, or you can simply pass in a structured array of a structured NumPy array inside vector.arr, and it would work out of the box. Okay, great. Moving on to awkward vectors, the vectors that you'll probably use the most. You can create an awkward array of vectors using the awk constructor or the AWK constructor, or this is the vector part of vector side of things, or you could directly use the ak.array functionality by calling vector.registerAwkward. So if you call vector.registerAwkward, you can create vectors using ak.array by passing the with name argument. So vector and awkward fit in together very well. Great. Then you have the Numba versions. As I talked before, the object backend and the awkward backend support Numba. And you won't see a very huge difference in performance for small calculations, but if you have like an awkward array with millions of vectors, then you'll definitely see a visible performance difference. These are some detailed resources for vector if you would like to dig deep into it. And yes, most of it is available in vector's GitHub repository and vector's README. Okay, so the important question now, but what's new with vector? So the first new thing, or the new things, are the new constructors. So all my previous slides were using old constructors in vector, which still do exist, but they are not going away. But they are a bit confusing and not intuitive most of the time. So for example, if you want to create an object type vector, you use vector.obj function. If you want to create a momentum type vector, you again use the vector.obj function, but this time with different arguments. So now each backend has their class constructors on, which means you can use the vector class itself. Like this particular example uses vector object 2D class itself to create a 2D vector from the object backend. And then there are other possibilities as well. So for example, class methods like from XYZ, and passing in the like going a bit going a bit lower level and passing in the azimuthal types or azimuthal, longitudinal, and temporal type objects directly into the vector object classes. And if you have been following vector, you would have noticed that these classes are now public, which I'll be touching upon in the next few slides. Okay, and similarly, we have the constructors for momentum type vectors. Okay, similarly, we have constructors for vector NumPy, the NumPy backend, and it works very similar to the object backend. So for the awkward backend, we don't have the vector array constructors, but rather the awkward constructors are uniform with awkward itself. So you have vector.array with a capital A that works similar to ak.array, and you have vector.zip that works similar to ak.zip. And we also have the original vector.awk function. Next up, awkward v2 support. So vector started supporting awkward v2 almost as soon as v2 was out, given that we were supporting awkward._v2 while awkward v2 was in development. But if you're still using awkward even, vector still supports awkward even, and this support is still tested. All of the versions of vector support awkward even, and there is no extra vector overhead for switching between awkward even to v2. So if you're switching your script or your data analysis pipeline from awkward even to awkward v2, you won't have to worry about vector at all. Everything will be handled automatically within vector, so you don't have to set up an environment variable or do any extra configuration for that. Everything's handled by vector, and both awkward v2 and v1 supports are tested in vector CI. We have a lot of new features as well. So vector initially was not very user friendly. So I mean, if you were developing vector, you were using vector from the moment it started its development, you would have known your way around vector, and you would have known what error messages meant. But if you're a newcomer or if you're learning vector for the first time, you would have found it very hard. So now we have a better user experience. So there are better wrappers, better error messages, better checks everywhere, and the private public API is segregated better. A lot of private API was made public on users' requests. There are also a lot of new methods. So for example, the two vector 2D, 3D, and 4D methods now support passing in coordinate values, and there are NumPy and awkward-like methods. Some count on 0, and then there are physics methods like delta rapidity phi and so on. And all of them are documented in vector's changelog, so you can check all of them out there. And then vector now also supports Python 3.11 and 3.12. There have been a lot of infrastructure developments in vector as well, but I won't be covering them in this particular talk. Moving on to bugs, vector now has less annoying bugs. So if you're using vector v 0.8.5, there was a possibility that your script would error out at the very last step instead of the first step, because there was it would error out on the last step because there was a bug in the first step of vector, which was in the constructors of vector. So now we have type checks in constructors. So now vector automatically rejects wrong inputs. The old constructors had a few bugs. All of them have been fixed, and the new constructors don't have any known bugs right now. And there have been fixes in vectors, properties, and methods as well. Oh, okay. Yeah, documentation. So as I said, the docs were not very good for newcomers previously, but now the documentation is now targeted towards vectors users and not the developers of vectors. So we've revamped the documentation completely. There's a better layout for the content. Everything's arranged better. There are more doc strings. Not every function has a doc string, but there are definitely more doc strings. The examples have been updated, and they are tested now in the CI. There are doc tests for a lot of public API now. So little examples in doc strings that are very helpful, and you're going through the API part. And vector also has a contributing right now. So much more happened in the documentation part. And we're also working on improving the documentation even more. And we're also participating in Hacktoberfest. So this is a very nice way to get involved if you would like to contribute to vector. Great. So where is vector now? Vector is in a stable place with V1 the first major release out. Development is being spearheaded by bug reports and feature requests on GitHub. There are no specific development target as of now. But if you create a bug report or a feature request, there are chances that we'll pick it up and implement that in vector. mostly voluntary development. I've been participating in Hacktoberfest. You can definitely check out the open issues in Vector. Okay, so future plans, what's happening in 2024 for Vector? There is a possibility of making Vector differentiable using JAX, which I'll be working on in the first half of 2024. And this will be tying up with with making the analysis grand challenge differentiable or adding autodep to ABC. But the work hasn't started yet. Great. So if you use Vector, you can cite us in your work, and these are all the contributors of Vector who made bug fixes and feature requests and so feature implementations and so on. Okay, thank you. I'll be happy to answer any questions, or you can get in touch with my website.